What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at part 8 of our tutorial series, Scientific and Numeric Computing in Python. So, if you have been following along with this tutorial series, you'd know that in the previous video, we basically looked at, a sort of fun activity or exercise regarding NumPy arrays. Essentially, what we did is kind of created a pattern, using NumPy only. So I have the script here. I will run this for us just so you can view, what output looks like to the previous videos, code. So this is what we ended up with, just an array of ones. This was after, we did some operations and some fancy indexing and so on to the array itself. So, in this video, we are going to be talking about quite an interesting concept or feature that is offered to us, by NumPy. So if you are a beginner, this will probably be super interesting for you. I know when I first discovered that NumPy has this kind of, capability and processing power, I was really intrigued. So let's get to it. So to give you a bit of insight, right? If you are learning about NumPy, the chances of you having done and encountered a concept called file handling, in your journey with Python, the chances are very high. So I assume you guys are familiar with what, file handling is. File handling. So it's basically having the ability to process files, okay? And Python itself supports file handling. Essentially, we can process files with Python. Now, reading and writing are two operations that are, involved in that processing, okay? Now, with regards to Python, and just in general, we're talking about scientific and numeric computing. File handling is very, very important because it is a crucial operation, right? Reading and writing data that is stored in files, whether it is in textual format or binary format, it is very important to understand how that works and how it's done, especially for scientific computing. Now, Python itself, right? Python provides us the ability to, save files. We can share files. We can read the data that's stored in files and so on. Now, Python is capable of doing all of these operations. And I think if we bring up the topic of speed, or, the factor of speed, it is obvious that Python is not as fast as your languages like C or C++, but Python is not, a bad option or choice, nevertheless, because Python makes parsing the file. So this is a word you need to be familiar with. Parsing, P-A-R-S-I-N-G, that basically means going through, okay, like processing. So Python makes parsing files very flexible process for us. It makes it robust, it's quick, okay. So before we proceed with the NumPy portion of file handling, I would really like to just give you a quick rundown into, the basics of pure Python file handling operations. So a quick rundown. What we will do is a simple read and write operation, and then we'll proceed to the NumPy portion of the work. You guys will see, open up in my Spider IDE. I have these two text files, sample text file 1 and 2. I suggest you guys pause the video, at these points, kind of take down the contents of these text files into your own local machine files and save these files in your current directory. Alternatively, you don't have to copy word for word. You guys can utilize existing text files that you have, okay? This is text file 1. We've got a simple statement that's been spread over several lines. And then we have sample text file 2. Essentially, this is like a 2D array, okay? We have columns and rows. So column 1, column 2 has floats, and column 3 has integers 1 to 6. And you guys will see when you are creating these files on your own, it's important to note that there are spaces. Spaces as in the space character that are separating the columns. So that's fine. Now let's get to it. I will comment the code here. So first things first, let's do a file handling operation using pure Python syntax. So opening the text file with the R option, which only allows reading capability. So this is kind of self-explanatory. I know you guys probably don't really need this sort of summary or about file handling, but I'm doing it just to accommodate those who maybe coded in Python but have not tackled or have grasped the concept of file handling fully. So all we need to know is a keyword that's built into Python. It is called the open keyword. It is a function, as you guys will see. Python's autocomplete and code helper is giving me a bit of information about this function. Essentially, it will open a file, and yeah, that's the main thing it does. The parameters that I need to pass to this function, there's two important ones I'd like to bring to your attention. So first, what I will do is I will head over to my IPython console and I will type open question mark. If you guys did not know this, if you are using Spider IDE, any keyword that's built into Python, any object, right? And by any object, I mean literally all objects that you work with in Python. If you type the name of the object followed by a question mark, okay, uh, Python will give us the built-in documentation for that object. So any bits of explanations or doc strings and so on, it will be returned to us. And the purpose of that is so we have a better understanding of that object or keyword or whatever it is that we are working with. Now let's do open question mark, and I'd like to bring your attention to two parameters, file and mode. Those are the two important ones that we need to focus on for now. File, that is self-explanatory. Guys, for file we need to pass in the name of the file that we would like to open for processing, because the open keyword will open a file for processing. The parameter file is the name of the file that will be opened. And mode, this is the interesting one. This is kind of the parameter that like sort of gives flexibility to the open function, okay? Because within the mode parameter we need to pass an argument, and that argument is really a single string character, okay? And that string character denotes and tells us what mode we are opening the file in. It defaults to R, which means that by default it is in read mode. All we can do with the file that has been opened is read the contents from that file. And here you have the various characters and their meanings for the mode. These are all arguments that can be passed to the mode parameter of the open function in Python. Okay, so you guys can have a look through that. And really, that's all you need to know for now about the open function. I have these text files. The first one I'd like to read is sample text file 1. So you guys will notice I right clicked and I went copy absolute path, and I will pass this as a string. So I'll place a comma, and one thing I always enforce, as you guys may know, is that typing the names of the parameters is helpful. Okay, it serves a purpose. So mode is equals to, it defaults to R. Okay, now what I would like to do next is I would like to read the contents of the file that has been opened, which is basically this sample text file 1. Now the way in which I will do that is I will set up a variable or an object to store the data that will be read from the file. I do f.readLines with a parenthesis. And as you guys already know or probably guessed that the read lines is a method that is used or can be called on a file object. And essentially what it does is it will read the entire contents of the file. It will store the contents in an array in which each element in that array is a line in the file. So I will add a small comment here for understanding purposes. Passing the file and splitting the data, or let's say splitting each line, which creates a list where each element of the list is one line of the, let's just say, file. Okay, so yeah, that's good. Now what I'd like to do is I would like to print a list. So think about this logically, guys. When we print a list, essentially what we are expecting is a list. That's the most important thing to keep in mind. We are expecting a list in which elements of those lists, each element rather, represents or is one line of data from the file that has been read. So I hit Control Enter and you guys will see I get this array in which my elements are the data of each line in the text file that we are working with. As you guys will see, hello appears on one line. There's a new line character. So file handling also requires that you be kind of familiar with just working with strings. Strings are important. I always said this in a previous lesson as well. Strings are very, very important because along with file handling or file processing, the next important concept as a whole in the whole of Python as a programming language is the concept of text processing. Text processing is a super interesting concept or topic. Okay, I will make a tutorial that covers interesting concepts of text processing. For now, all you need to know is that the \n is the string formatting character which represents a new line character. So essentially, if I did not have access to sample text file 1, if I did not have direct access, maybe the file was somewhere on my computer, or rather maybe the file was too large to open on my PC. Now what I could do is I could read a portion of this file, and just by looking at the output array itself, being guided by the string formatting characters, I can tell that in this file the first line has the word hello. There's a new line character after hello telling us that I move to the next line. On the second line I have the word world. There's a new line. So on the third line I have the word I. There's a new line, and so on. So as you guys can see, it's just kind of flowing. Okay, it all flows and just comes together. So that is essentially the most important concept of opening a file. Now, paired with opening a file, okay, these two are kind of, I would, logically speaking, it is one operation. Opening and closing a file should be done in one operation. So f.close. Now all this does is this close method. Again, this close method needs to be called on a file object. And as you guys will guess and know, that the close method will close the file that we have been working with. Now you may ask yourself why. Okay, why close the file? So closing the file is actually very good Python practice. Essentially what it does is it kind of frees up RAM, and that's the most important concept. Okay, it avoids memory being allocated or dedicated to an object that is not being used. Okay, because after we have finished processing the file, essentially the question we'd ask is, why would we still want to keep the file open in RAM? We can just close the file. So to do that, we use the close method. I will add a comment here for you guys. So it is very good Python practice to close a file after your processing operations have been completed. So that's good. That is the first portion that I wanted to demonstrate for you. That was simply us reading a file. Now, what I'd like to do is I would like to just demonstrate the concept of writing to a file, because really guys, read and write are two of the most important operations that you should know if you are looking to get into file handling. So let's proceed to do a write operation. It is easy guys, you guys will find this interesting. So essentially, let's theoretically say that, you know, we had this file, we finished do a whole lot of operations on it, and now after extracting some information that we want, we now are prepared and we are ready to write that information to a new file, so we can just access that new file for the important information. So this is how we would go about doing it. So it is easy. F is equals to open, and you guys can call your file object rather, you can call it anything you like. Okay, I'm just calling it F. That's because it makes life easy for us, and in most tutorials and books and resources, really I would say the norm in inverted commas to call your file object is by the name of F. So it just makes life easy for us. So we'll do open. In a string, we will pass the name of the file that we want to open. Now, you guys may ask, right? What if we are opening a file that does not exist? Okay, so I'll give you an example. Suppose, you know, so I have sample text file 1 and I have 2. I don't have sample text file 3. But what if I passed, you know, open sample text file 3.txt? What if I pass that as an argument to the open function? Now, the most important thing to know is that you won't get an error, okay? Because if the file does not exist, Python will actually create a file by that name, and then you will proceed to do the operations that you want to do on that file. Okay, so I will demonstrate that for you now. So let's say a comment, open a new text file to write the data with the W option. If there is no file by that name, a new file will be created and worked with. Now this is another important thing you need to know guys about the open function being used for a writing operation. This is super important, okay? If there is data that already exists in the file that you are opening in the write mode, then the existing data in the file will be overwritten. This is very important, guys. You guys must keep this in mind, especially if you are working with, crucial statistics or information. Okay, if you are opening a file that exists, if you are opening it in write mode, and say you kind of in the moment forgot that your important information is in that file, and if you open it in the write mode and attempt to write, essentially what will happen is, first, the contents of that file, all the existing content in that file, will be erased, and then your write operation will take place. So keep that in mind. Now let's do f.write lines. The writelines is a method that can be called on a file object. In our case, that file object is f, and within the writelines method, we pass in an iterable or a sequence that we want to write to the file. In our case, let's just pass in, a list, because a list was an iterable. In other words, a sequence, it was an array. So now I do f dot close. So I have not ran anything as yet. I am going to do that now. So let me just add a comment here. Utilize the dot write lines method to write data to a file. Now I am going to press Control Enter, and I want you guys to keep an eye on this directory in which I am in. Okay, keep an eye on the directory, and you guys will see that sample text file 3.txt is going to show up in this directory. That is because of the f is equals to open line of code. So I do Control Enter. So okay, guys, I actually forgot to include a mode here. That is my bad. So W, don't forget to add that. That's like the most important thing. So Control Enter, and as you guys can see, sample text file 3.txt. And if I double click this file, it will open. And take a moment to, think about what are we expecting to see in this file. Remember, we wrote a list to this file. So now double click, and here we have it. Essentially, sample text file 1 and sample text file 3 has the same data. They have the exact same information in them. So let's close 3. That is a standard, interesting way of handling files in Python. A simple, file handling tutorial that was. We can dive in deeper into this in file handling concepts at a future tutorial. I just wanted to give you a rundown. The reason being, let's talk logic. What we just did was file handling. We understand that. File handling allows us to read and write data to a file. We can access data, we can record data, or in other words, save data. What we just did, yes, I would say to some extent it was fast. It is quite flexible given the fact that we have the ability to write, almost instantly to a file. But there's one downside, okay? What I just demonstrated to you was kind of a small scale operation. You guys will agree, all we did was read and write 9 lines. Okay, that's a joke for our CPU. Now the question is, what if the file has 100,000 lines, for example? Okay, then obviously logic will tell us accessing or modifying or modulating that data is going to become a very cumbersome process for us. It's going to be slow. Okay, now think about it, guys. The data that we read and we write, it is all stored in an array, and in our case we call that a list. Okay, there's a list on the screen right now. Now if I do type of a list, it is a list. It's a standard Python list or array object. Now the question is, what if we have the ability to get that data directly into a NumPy ND array. Okay, now as you guys probably already, kind of thinking and smiling to yourselves that having the ability to get the data, those lines of information, into a NumPy ND array will give us the boost of performance, okay, of accessibility, speed. It's going to give us a massive boost in speed, and that's going to be our best option if we want to increase the speed of this file handling processes. Okay, now this is an interesting portion. First I will do our well known, so let me just come here, delete that. So import numpy as np. So I won't comment the code for now, guys. We'll just talk about this. I'm talking some logic first, and then we'll proceed to actually work hands-on. So another thing I should mention, oftentimes you will find me talking about a concept first and having you just listen to what is being said about the concept, and after that, after the discussion, we actually proceed to work hands-on with the concepts that were discussed. So I don't know, I find that a very effective and efficient way for me to learn my work. So the reason why I adopted that kind of, I would say, trait into IT is because it's the way in which I learned physics in school as well, and it really did work for me. So yeah, so having done both physics and IT, I kind of see them, I think with regards to difficulty and logic processes, they are on a very similar level. So yeah, that's that. Now let's talk. So what we witnessed earlier was file handling using basic Python syntax. Now I am going to demonstrate to you, and we are going to have an interesting journey of file handling, okay, but using NumPy, the package and arrays. Okay, now NumPy has methods, functions, features, whatever you want to call it, you can call it. But we have these functions and methods that are available to us. Now, interesting and important ones is actually called, I will caps lock this, so numpy.loadtxt. Okay, we have numpy.loadtxt. This is used for loading data from a text file into a NumPy array. That's the first important method that we need to be aware of. Next, we have this function or method that is called NumPy. Let me do np dot save txt. So as you guys will probably already know, the read lines and the write lines work very similar to, oh, actually I should phrase it such way. In standard Python file handling, the read and write operation is basically done in NumPy using load txt and save txt. The load will be used to read and the save will be used to write. So that's interesting there. I will do a comment saving data to a text file, NumPy array to a text file. So they are kind of opposites. Load txt will get the data from the text file into the NumPy array, and save will get the data from a NumPy array into a text file. Okay, so we will witness this shortly. Now, it is important for me to reiterate that we are going to be utilizing majorly sample text file 2. Now let's proceed to do that, guys. So I've imported my NumPy package. Next, I would like to do ARR. You can call your object anything you like. I mean, given the fact that we are storing the data in a NumPy array, you can call yours, ND array or something to that effect. So np.load txt. Within the load txt function or method, I would like to just mention two important, uh, you know, parameters. So we have fname, which, as you know, is the file name. Fname is equals to, and then we have dtype. Okay, dtype is the important one. It's the one I want us to focus on, a bit extra. So for fname, suppose for this test run, as I said, I'm working with my sample text file 2. I will do I'll just copy paste the absolute path. You can give yours as well on your local machine. So fname is equals to, and I have the path to the file that I want to open up and load into a NumPy array. Now dtype is the important one, okay? Because you see, there are two ways to look at this. There's the easy way and the hard way, okay? But I mean, I wouldn't really call it that, okay? Because I mean, it's all interesting. So like, I mean, think of it such way. The easy way in inverted commas is when you are dealing with a 1D array, and the difficult way in inverted commas is when you are dealing with an array that has 2 dimensions or more. Okay, so what we are doing is working with an array that has 2D or more. Because think logically, guys. This here, sample text file 1, this is a 1D array. How do we know this? Because it's as we've been working with NumPy arrays from the beginning of this tutorial. Okay, this has 9 rows, but logically speaking, if you look at this data, it's all in one column. Okay, whereas if we hop over to sample text file 2, this has 6 rows of data and it has 3 columns. So it's a 6 by 3 array, whereas this is a 9 by 1. Okay, row first then column. So I hope this is making sense to you guys. And yeah, that's the important stuff there. So let us now proceed to actually array is equals to numpy.loadtxt. Now I want to print. So let me first mention, see, I actually almost forgot about this. So dtype. Now it's easy, dtype is the easy parameter to actually sort out when you are working with, an array that has 1 dimension. Why I say that is because you see, is an array is called an array because of the fact that all elements inside it have the same data type. Okay, this is Python basics, guys. You guys probably know this already. Now, an array is an array because it has elements that belong to the same data type. As in this case here, sample text file 1. Yes, there are several elements, but they are all string data type. Therefore, it is a 1D array. Now, if we look at sample text file 2, this is not a 1D array, and apart from that, looking at the data that's within this array, it is all having, it can be of a different data type. And as we see, here we have string, here we have float, and here we have integer. Okay, now in the event of us reading a 1D array, all we would do is pass the appropriate character that represents the data type for that 1D array we are working with. So in this case, since there are strings here, we would have just passed S maybe 4. So we did cover this in a previous tutorial, right? In the previous lesson, I spoke to you guys about the special characters. I wouldn't really call them special, but they are those format characters that kind of denote the data type that we are working with. So S was for string, and the 4 basically represents the number of bytes that we wanted. So 4 bytes, which is basically 32 bits. Okay, so in the event of us wanting maybe integers, we do an I. If we wanted float, we do an F, and so on. Now, for this simple file, we would have just done maybe S4, okay? But we cannot do the same here. Technically, we can, right? But if we only pass in s, essentially what's going to happen is we are reading the entire array as a string. So let's proceed to do this. I want you guys to get the full effect of what I am talking about. So print arr, let me cut that, just place that here. So I do my printing operation, and as you guys can see, I have this 2D array as we expected, right? That does not come as a shocker to us. We did expect a 2D array. If I proceed to check arr.shape, a 6 by 3 array as we expected. Now the thing is, in the file itself we have string, we have float, and we have integer. But in the array, or rather in the way in which we read in the data from the array, we've actually interpreted everything, all values, as a string. And this is not, this is not the raw form of the data. This is a tweaked or manipulated form of the data. So how do we get, the data to be in a NumPy array, but in its raw form, where we have the ability to have an array that can have elements belonging to different data types. So I really hope you guys remember this concept. We spoke about it in an earlier tutorial, and it is making an appearance now again. It is called rec arrays. Okay, I do hope you guys remember this. Leave a comment down below if you have followed and if you were on par with this rec arrays concept. So rec array is basically record array. Okay, record arrays give us the ability to have multi-dimensional arrays in which columns of that array can have elements that belong to different data types. Because I've been telling you guys from the beginning, okay, think of an array, a 2D or more D array, as a table. Okay, and in a table we have rows, we have columns, but all elements in all rows, or in all columns rather, they are not the same. You don't find, or you rarely find, tables like spreadsheets in which all columns store string values. Okay, they will differ. You'll have string, float, boolean, this, that, and so on. So record arrays give us the ability to do that, but with Python and with NumPy. So I hope you are finding this interesting. So essentially what we are faced with now, we have a situation. I have successfully loaded. So let's do one more thing. Type of arr, and as we see, it is a NumPy nd array. Now that is a good sign, the fact that we are working with a NumPy nd array. But the situation we are faced with now is that my values, the values in my columns are not as I expect it to be. Okay, it's all showing in strings because of the fact that I read the entire contents as a string. Now, I'd like to mention to you guys, there are more than one ways to get your array to a standardized form. By standardized form, I basically mean, as I'm saying, we want the first column to be string, we want the second to be float, and the third to be integer, because that's how our text file looks. Now, there's more than one way to go about getting to that end point. Okay, the way in which I am showing it to you now is the way in which I find it is kind of very logical, and it's very nice and easy to follow along, okay, to understand what's happening. So I will demonstrate that now for you. Now, essentially, all I am doing is getting my columns. I'm isolating my columns. Okay, each column and the associated values in it, I am isolating it. How do I do that? I do that using a simple slicing operation. Okay, slicing is something we've covered in a previous lesson as well. All I am doing now is getting column by column. So let's do that manually. Call 0 is equals to array. So column 0 is this here, the one that has the XR elements. So let's do, I want all rows and I want column 0 dot as type. So I will come back to that. So call 0, call 1, r 0 1. I'll copy paste this. 2 0 1 2, 3 columns, 0 1 2. So that's that. Now if I proceed to actually run this and I want to just check what column 0 looks like, so as you guys will see, it is all strings. Okay, column 0 is all strings. Now if I view column 1, it is all strings, but column 1 is not supposed to be strings. Okay, now this is what we do. It's as follows. Now I'd like us to come back to call 0 is equals to array colon 0, and what we are going to do is dot as type. Okay guys, so I just see now I actually misnamed my object, so I had two call ones, so I've kind of fixed that. So what I will do is just run this again. So now if we view call 1, correct, it is the floating point. So earlier it was showing us the last column because I actually accidentally had two ones. So it is sorted out now. Coming back to what we were doing, you see, call 0, that's fine, it was meant to be a string anyway. Call 1, however, it is supposed to be float, but we see that it is a string because it has the B format character. B is basically bytes and it has quotations around it. Okay, this is not what we want. So essentially what we will do is call 1 dot as type. I am doing this in the IPython console so you guys see what is happening. Okay, float call 1 dot as type float. We've covered the as type function as well in a previous tutorial. So if I hit enter, you guys will see what's going to happen. This is what call 1 was, the string, a string of bytes, and after the as type, which is basically the casting operation, we have an array in which there are floats. Now what I would like us to do now is apply the same logic to the script itself within the editor. One more thing I'd like to just show you, okay, is so we have call 1 dot as type float. Now let me do a dot shape, and as you guys will see, it is a 6 by 1 array. Okay, a 6 rows by 1 column. Now the thing is, okay, it is not known whether this array whether it is a 6 by 1 or it is a 1 by 6, because if you remember correctly, I explained to you in the previous lesson, in one of the earliest lessons that we did, that logically speaking, okay, a 6 by 1, this is an example, right? I'm working with the number we have here. It can be anything, okay? It can be a 4 or 10,000 by 1 and so on. So a 6 by 1 array, logically speaking, is not different from a 1 by 6. Okay, it's the same array, just spread over in dimensions. Okay, so logically speaking and theoretically speaking, when it comes to this specific portion of NumPy, okay, when you are working with record arrays using the load_txt function, we don't necessarily know what the shape of the array is, whether it's 6 by 1 or whether it's 1 by 6. Okay, Python tells us a 6 by 1, but this is not explicit, it is not confirmed, it is implicit. Python just tells to us that this is a 6 by 1. Okay, the way in which I can make sure, I can firmly say that this is, a 6 by 1 array, for example, is if I specifically and I explicitly tell Python to make it a 6 by 1. And remember, these are 1D arrays. So the way in which we will do this is using the reshape function. I can specifically or explicitly reshape this 1D array to be the shape that I want. Do I want it to be a 6 by 1 or do I want it to be a 1 by 6? So I hope this is making sense to you. Okay, so for this, what I want is, I want it to be a reshape 6, or let's do it the easier way. The easier way is as follows. So -1. -1 is to say unlimited. So unlimited rows, as many rows as there needs to be, but everything must be in one column. And if I do dot shape, you guys are going to see it's explicit. Now it is explicit. 6 by 1. I know for a fact because it is explicit. We have explicitly coded that this array col1 is going to be as many rows as there needs to be, but everything will be in one column. So I hope this is making sense to you. And then we just checked the shape of that array. Now, taking the logic we've just implemented here in the IPython console, let's hard code this to the portions of code we have in the editor. So as type, so dot as type, you guys know col0 was the string column. It was or is already in string. We don't have to do it, but I am doing the as type just so we have some sort of consistency. So string dot reshape, and I want unlimited rows, as many as there needs to be, but I want everything to be in one column. I will copy paste the portion of the as type and I will paste it to all, because a fact is that I want the new array that I am compiling, I want there to be consistency. I want all values to have or occupy as many rows as they need to, but everything should be in one column. And think about it. If we are working with a 2D array, which is like a spreadsheet has, even though there may be null values or missing values in that spreadsheet, a fact is it will occupy across all columns the same number of rows. Okay, so think about that. Now, what I'd like to do is, I would just like to adjust the as type that I am casting to. So 0 was string, 1 will be a float, and column 2, which is basically, if you guys forgot, it's the integer column. There's it here. This is the array. We will do this int. So I run this, and now what I'd like to do is column 0. So this is just us interacting with the IPython console. The IPython console is very, very helpful, guys, as you can see. Now, take a moment to look at this. This is our new column 0. The bytes formatting symbol is gone because we know for a fact that this is a pure string now. It's a raw string. Then we have column 1. Column 1 is an array. Here we have the floating point values. Column 2 is this array of integers. Okay, now think about it. We have these 3 columns in the respective order, but they are all separate. So the question is, how would we get these columns to kind of be placed side by side, next to each other? So this leads me to talk about another interesting function. I won't dive too deep into this function, okay? It is a relatively simple one. So as you guys will see, I set up ARR. You can call yours anything you like. Use the one that you've been using though from the top, from the time you read in the text file. So or you guys can name it anything you want, right? Because we are creating a new object. So I'll just call mine R, okay, ARR. So np.concatenate. So if you are familiar with spreadsheets as well, then this is really going to be very simple for you to understand. Okay, so the concatenate is basically, concatenate is a fancy word for kind of like join or bring together. Okay, and essentially what we are doing is we are bringing, now we attempt to bring these three arrays together called 0, 1 and 2, and we are bringing them together side by side, okay, next to each other by the column. And what I will do is, within the concatenate function, I have a tuple and I pass the iterables or the sequences of values that I want to concatenate. So column 0, column 1, column 2. And it is good to know that it requires all the sequences that you pass to have the exact same number of elements. Okay, this is what makes the concatenate function always work for us. So we have a 6 by 1, a 6 by 1, and a 6 by 1. And we attempt now to concatenate it. So if you think about it logically, the end result will give us a very neat 6 by 3 array. So I have my tuple of sequences, I place a comma, and I do access is equals to 1. Now access is equals to 1. Access is something that's also important, especially if you are working with arrays. All I will tell you is that when an access is equals to 0, we are talking about rows, or let's say operations done row wise. When we are talking about an axis of 1, we have operations done column wise. Okay guys, so you see essentially what we are doing now with an axis of 1, it is telling Python that each of these arrays should be placed next to each other. So essentially this here, this array here, will be placed to the right of col 0, and this here, col 2, will be placed to the right of col 1, because that's the order in which we passed it in. If I passed axis is equals to 0, okay, essentially what will happen is that we have col 0, but now this col 1 will be placed under col 0. So essentially we would end up with a like kind of a single, a one-dimensional array. That's what would happen. Okay, I hope this is making sense to you. Now what I'd like to do is run the script because we are done. Okay, so print r, and here we have it. This is the final array representation. It's a NumPy array, yet we have tabular data that is stored in it. Okay, and to take this to the next level, this is extra information. I mean, doing YouTube also enables me to learn a lot more. So I actually went searching for this feature, because when we actually had the ability to give column names to the initial rec array tutorial or lesson we did, I actually asked the question if we can name the arrays, using other built-in Python packages as part of NumPy. So I uncovered this: import numpy.lib.rec functions as rfn. Now NumPy has a dedicated sub package that is meant for record arrays. It contains record array functions that can be applied to our record arrays. So it's an easy one that I just want to demonstrate to you. It's going to enable us to give column names to this array. So let's do array is equals to rfn dot unstructured to structured. Within this, we pass the array itself. In our case, it's array, the one we've been working with. And then I pass dtype. Dtype for each column, right? I have the ability to pass a column name as well as the dtype of that column. So I do np dot dtype. And within so the dtype itself has a pair of parentheses, as you can see, and inside the parentheses I will pass a list containing tuples. So there's my list. I give tuples now, and each tuple is going to consist of two elements: the name of the column and the data type of the column. So I do call, or let's be fancy, so we can call this maybe id, comma, this is a string which is 4. I have another, so I will space this out for you guys. So I have id, maybe I want to call this result. Column 1, basically it was in the form of a float, so f4. And then we have the last one, maybe we can just call this type, for example. And let's do integer 2. Okay, an integer consisting of 2 bytes, which is 16 bits. Now what I have the ability to do now is to run this, and when I run this, you will see that it is in the form of a structured array. This is a structured NumPy record array. Essentially what it does for us is it gives us the ability, forget about the representation of this array, okay? This having these column names, this is more for, EDA. That's why I said it is extra. You can stop right here if you want, but to take it one further, you have the ability to do this. So for EDA, that's basically when you are exploring your data. If you would like to get, your elements or your values column by column, if you want to separate each column from the next, instead of accessing it by slicing operations, which is kind of cumbersome, especially if you are working with large amounts of data, it would be super convenient to access the data from the column names itself instead of just slicing using the indices. So that's what this allows us to do. I will demonstrate for you. So let's do a print. I will comment this out for now. I'd like to do print arr, and the name of the column that we have within the array is id, result, and type. Let's say I want let's do id. id was the kind of fancy one, and here you have it. As you can see, we have the id column from the record array. And remember guys, all of this is actually possible using only NumPy. Okay, so Python is kind of cool. I mean, this just gets me to like the programming language even more. And this, now we see that array id, so basically the id column, the first column in that array, is a NumPy ND array. So this confirms that yes, we are still working with a NumPy ND array. So really guys, I think I will end the tutorial here. We have covered super interesting concepts in this video. This is probably one of my favorite videos I have on the channel. It is 58 minutes. I think it is the longest single video on the channel. So yeah, with that guys, thanks for watching. Thanks for staying till the end of the video. And thanks for using my channel to educate yourself, Do make sure to leave a like for the video if you enjoyed it. Subscribe to my channel. That really motivates me to create more such content for you. And yeah, feel free to connect with me on LinkedIn. Comment down below if you liked the video. Good luck with your work, and I'll see you in the next YouTube video.